This is giving me a headache. Hey everyone, welcome to my channel. My name's Tara. We're going to dive right into this. You can probably tell from the title that this is a scientist answers the most commonly Googled questions about scientists. Okay, so the first thing that we have here is, can scientists create life? The short answer is no, not yet. I mean, that's one of the big scientific struggles at the moment, is people have been trying to create life essentially from scratch. But it's not something that we've been able to do yet. We can create lifelike forms, cells that have functions that mimic life, but what we define as something that is living has not yet been created. Can scientists make water? Theoretically, yes, we can. We know what the molecular formula of water is, which is H2O, or 2 hydrogen atoms and 1 oxygen atom together in a molecule. However, to achieve this, or to get hydrogen and oxygen to come together and form this molecule, is extremely difficult, both economically and practically. So in order for this reaction to occur, a lot of energy gets emitted all at once in essentially a catastrophic event, and hydrogen is flammable and oxygen basically feeds combustion. And so while we could theoretically achieve this in the laboratory by bringing these two things together, it wouldn't be practically or economically viable. The other option is to draw, I guess, water which already exists as water vapor in the atmosphere and condense that into water, which can be done. So it's, if you've ever heard of the Whiston windmill, it actually achieves just that. So while it's not really viable, I guess, for us to just make water, there are other options to be able to actually extract it again from the atmosphere, but it is an expensive technology, and we still need to work more on it. But yeah, we can, but we can't. Oh, we've got two that look similar. Can scientists bring back dinosaurs? And can scientists make dinosaurs? Oh, and can scientists recreate living dinosaurs? The answer is no. Well, the most obvious way would be to clone dinosaur DNA. However, scientists haven't found any of that because DNA doesn't survive that long. So while there are still people searching for this dinosaur DNA, we currently don't have it, so we can't clone it. The other option would be to reverse engineer it, but we are still a long way off before we'll be able to do that. So apologies if you wanted Jurassic Park to become a real thing, but right now it doesn't look like it's going to happen, and it's probably for the best. Since our ecosystem is already very fragile, introducing new species would probably be not a good idea. Okay, next one. Can scientists have tattoos? Yes, they can have tattoos. Hopefully you can see them. So yes, you can. But I guess obviously, just like any industry, there is still stigma behind having tattoos. But that's definitely getting better as time has been going on. So yes, don't hold out on getting tattoos just because you want to be a scientist. Can scientists control the weather? No. No. Otherwise we would be able to stop things like the hurricanes and tornadoes from occurring, and obviously that's something that we can't do. We obviously have some very advanced tools that are able to predict these natural disasters, but no, the weather is controlled on an earth-wide scale, so I can't imagine that's something we're ever going to be able to do as much as we would love to. Okay, so this kind of ties into the last one. Can scientists predict earthquakes? We can predict a large earthquake that's coming on, for example, if there are tremors in the earth. However, prediction in that saying, oh, in 2 years' time in this exact spot, there's going to be this magnitude of earthquake. No, we cannot do that. But we do have advanced technologies these days that can allow us to, again, detect tremors or foreshocks that can happen in advance of major earthquakes, and then we will obviously get hopefully some kind of warning before they actually occur. All right, I'm glad that I did this one. All right, we'll start with the simple ones. Do scientists know what gravity is? So yes and no. I think that's going to be the answer to a lot of these questions. While we know how gravity behaves, so we know that if you have an apple, just like Isaac Newton said, if you have an apple and you drop it from a tree or let go of it on a tree, the apple will fall to the earth. And this is due to the force of gravity. However, in a fundamental way, we don't really know what gravity is per se as a force, but we know what it does. And hopefully that is enough for you. Do scientists make a lot of money? And do scientists get paid? Oh, this is gonna make me sad. Do scientists get paid? Most of the time. They should get paid if they're working, which essentially what science is. Do they make a lot of money? It depends. It depends where and in what type of science you're doing, if that makes sense. So in academia, for example, if you're a professor and you look after a research group, or if you're a lecturer who teaches university students, those levels of pay are usually quite high, but the lower down you go, the worse it gets. So for example, as PhD students, which is what I am currently, there is a global problem where most people agree that PhD students are underpaid. So we get paid, we're considered both students and workers, but essentially we're working full-time, but we get paid not very well. Usually the stipends that we get paid are below minimum wage. If you want to read a bit more about that and sign a petition, my online friend Naomi has started one, and she's currently a PhD student. So I will link that somewhere here or somewhere down there if you want to go help out there. But then obviously if you go into industry, again, it depends on your level of experience, sometimes what degrees you have. Whether you come out with a bachelor's, you might start off at a lower rate of pay than someone who has a master's or a PhD, but it depends on where you work, essentially. If it's a big business, they might be able to afford to pay you more, but in academia it's a bit of a haul. Do scientists believe in astrology? Well, I mean, I can't speak for all scientists ever, but no. Astrology versus, say, astronomy or astrophysics. Astrology is the study of horoscopes, essentially, and is classified as a pseudoscience. And then astronomy, astrophysics are obviously looking at space and celestial bodies and phenomena. So there is no scientific basis or evidence to show that astrology is real. The fact that what time of year you were born can place you into, say, certain categories. There's no scientific evidence for it. And again, like, people can have their own beliefs, but most scientists would say no, because there is no scientific evidence, and that's what we base our whole lives and our careers on, I guess, is looking at the evidence. Are scientists doctors? Well, some of them, yeah. Depends on what type of doctor you mean. There are doctors like medical doctors, so the ones that if you go to the hospital, those are medical doctors most of the time. Or if a scientist earns what is called a PhD or a doctoral degree, then once you finish that degree and you pass it, essentially you become a doctor. So hopefully when I finish my PhD, So hopefully when I finish my PhD, assuming I pass with flying colours, I will be Dr. Tara McDonnell. Also, in saying that, just because you don't have a PhD or just because you don't have a degree at all, even if you don't have a master's or even a bachelor's, that doesn't not make you a scientist. At the end of the day, anyone can be a scientist. You just have to be curious and use what we would call the scientific method, where you come up with a hypothesis and then you test the hypothesis and then you use evidence to figure out whether your hypothesis was right or wrong. Just elitist thinking to think that you must have a science degree to be a scientist. If you're coming up with a hypothesis, any type of thing where you think this might happen, and then you test that, and then you can compare what happened versus what you think, that's part of the scientific method, and that's part of scientific thinking as a whole. So yeah, there are scientists who are doctors. There are also a lot of scientists who are not doctors. You don't need a degree to become or to be a scientist. Sorry, that was like my little rant. We're just gonna keep going. Why scientists consider the biosphere to be fragile. Most of life on Earth exists within only a few degrees, and it can't function above or below this certain temperature range. So if we're talking, for example, out about climate change, if the global temperature rises and rises, there are certain things that can't survive in temperatures above that
range.
And while we obviously can see adaptations in species, that's over a long period of time. So if we alter things in a very short period of time, species can't adapt, and then they die. And when, for example, if you've heard of like food chain, food cycles, if a species of bug dies that another, say, spider eats, then the spider can't get its food, then those spiders can die, and then whatever feeds on those spiders will then die. Don't know why I use spiders as an example, but yeah, the idea is everything is interwoven with one another, and while there is this ability for adaptation, it's not necessarily possible it isn't possible in a really short period of time. Hopefully that kind of answers your question. Why do scientists refer to blood as tissue? Do scientists refer to blood as tissue? I'm gonna look that up. Oh, okay. So it says blood is considered both a tissue and a fluid, and this is essentially because it's a collection of similar specialized cells that perform a particular function, just like, say, your brain is a collection of neurons and glial cells that perform a specific function. That's why it's considered a tissue. And then obviously the cells are suspended in a liquid matrix, i.e. your blood plasma, which makes it or allows it to be considered as a fluid as well. That's really interesting. Why do scientists classify living things? It's just kind of like a human thing that we do. We like to box everything and anything into categories, right? For example, I have brown hair, I'm a brunette. My friend might have blonde hair, she is a blonde. So we like to categorize things because it makes us easier for us to kind of recall information and remember things. So it's just kind of, I guess, a human thing as opposed to a science thing. We have like different proteins are classed in different families. You'll have different molecules in chemistry that are classed based on certain groups that they have in them. So it's just something that can make it easier for us to understand complex things by boxing them into these certain categories. How they get boxed, though, is completely dependent on what, I guess, parameters you're using, though. So you could look at, say, again, if we think about marsupials, for example, they're mammals, but they lay eggs, right? So if two people looked at it, someone goes, I'm going to classify, there's the animals that do lay eggs and the animals that don't lay eggs. So for example, echidnas, which lay eggs, would go in with the same category as snakes and lizard. And they wouldn't go in with the mammals. Whereas if you then went, okay, well, everything that's warm-blooded, they would obviously get categorized in with the mammals, and they wouldn't go in with the things like the lizards and the snakes because those are cold-blooded animals. So how we classify living things is kind of very arbitrary based on what we're specifically looking at. So if it's actually a good thing or not that we classify them, it's debatable. But essentially that's why it's easy for us to understand complex things. Why do scientists use microscopes? We essentially use microscopes when we're looking at some things that are so small that they can't be seen with the naked eye. So if you look at an ant, you can go, okay, these are the basic structures of an ant with my eye, but there's only a certain degree of detail that you can get from just looking at it with your eye. So using a microscope, just like using a magnifying glass, lets you see a greater level of detail in things at a smaller level than what the eye can see. How are scientists and engineers different? I mean, there is a huge overlap between scientists and engineers. Most people kind of make the generalization that scientists are trying to understand how things work, and then engineers take this understanding and then adapt it or develop it into do a specific form or function. But just because I'm a scientist, it doesn't mean that I can't then adapt it. So there is kind of like, it's a very blurred line, if there even is a line that exists. But I guess that's kind of people's general idea, is scientists are trying to understand and ask the questions of how and why, and the engineers try to then use the information that we know to make something better or create new things or new designs or new inventions.
Hey, just me popping in to say, if you have any questions, you can ask them down below and I'll try to get to you as soon as possible.
How are scientists like detectives? Okay, this might be my favourite question. I guess we're like detectives in that we find clues and then we try to figure out from these clues what a certain thing means or how it got there. That's great. I want to call myself a detective now. Why scientists use models? Basically, models get used when we can't use the real thing to test whatever we want to do. Essentially, the idea is to be able to kind of create a basic understanding of something without actually seeing or doing something in the system that we're trying to look at. Why do scientists use the metric system? Because it's easy to convert and do the mathematics between different things, and also just because the fundamental constants have been set up using a metric system, and usually people try to work with these constants. Why are scientific journals so expensive? Oh, you and me both. Because scientific journals make money off people buying articles of them, off of them. So they can set their own things. That's a whole other issue that we're not going to touch today. Scientists don't make money off the journals. So if I publish an article in a journal and then you pay to see it, I don't make any money off that. The only people making money are the journals, which is, again, a broken system. But yeah, if you ever want to read someone's article, send them an email, which will be in the article. It's like the first page of the article, and they'll more than happily send it to you for free, unless they're weird. Scientists will never tell you this. Oh, okay, and that's where we're ending the video because that just makes me upset. I hope you enjoyed this video. If you liked it, you can subscribe. I mean, I think that's what YouTubers say. Also, my socials are down below. If you're interested in what scientists in research, in academia, in higher education actually get up to on a daily basis, you can click the link below. Check out my Instagram. I post there regularly about daily scientific life, the goods and the bads. So yeah, feel free to follow me. But yeah, hope you enjoyed. See ya. That's my brother.